Okay. So in the collection frameworks, we discussed about we studied about a brief overview of generics, how to define the generics, what are generic methods, classes, interface. Then we studied about util package, collection framework, like so we studied about what is iterable interface. So what is iterable interface? We use it to iterate, right? So the collection interface set. What is the set used for? For the very good unique list, ordered and duplicate queue, first in, first out, double-ended, right? And then we studied map also. It was a key value pair. And in the sorted map, what was there? The key was sorted. Okay. So here are the few implementation classes. Like for the set, we have hash set and linked hash set, as well as tree set. For the list, we have array list, vector, as well as linked list. For the list also, see, linked list is extending abstract list also, and also it is implementing dequeue. So linked list can act as queue as well as a list. Okay. And also about the queue, we have priority queue as the class implementation. For the hash map, for the map, we have hash map and hash map key value pair, linked hash map, as well as we have tree map. Tree map is for sorted map. So these are the few implementation classes. So if we have some time, we'll discuss in detail about each one of them, but we've already discussed like what basically are the list and all. But if you have time, we'll discuss in detail. So today what we'll start with, we'll cover few small topics. So here we'll start with a comparator interface. So why do we use comparator? So with the naming comparator, what do you use? What do you think? What was the use of comparator? To compare it, right? We compare it to check whether the value is small or large, simple. That is the use of comparator. Now, tell me, like for the integer 1 and 2, like suppose there is an integer 1 and 2. They can be compared, which is smaller. 1 is smaller and 2 is bigger. That we can easily compare. String also we can compare based on the ordering, like A comes first, so it may be smaller and S comes last. But tell me, if I create an object, where it has field like age, let's suppose I create an object which has field like age, name, or class, roll number. I have two objects. Now, can you tell me, can we compare these two objects? Like if I want to find out which object is smaller, which object is larger, how can we do? Ideally, it's not possible, right? What should we compare, right? Should we compare age? Should we compare name, class, roll number? And an object can have multiple such attributes. It has methods and all, right? So to compare an object, it's a difficult thing. So to find out which object is smaller, which object is larger, it is the responsibility of the developer. Why? Because it is us who is, we are defining the object, we are defining the field, so we know much better than other, right? Java cannot provide us any default implementation, right? Because Java don't know what field you will use, what will be the object will be containing. So to define the ordering, okay, which one will be smaller or which one will be larger and all. So what Java has done, Java has provided us a comparator interface. Okay. So using the comparator interface, if it is an interface, what does it denote? If it is an interface, then it will have some abstract methods which a class should be implementing it. Okay. Why do we use comparator interface? To define the custom ordering logic to sort the objects. Okay. So it allows developers to specify how objects should be compared and ordered without we modify their class definitions, right? We have seen we cannot, like Java cannot by default compare an object. It doesn't know about the object, right? So where it is used with sorting algorithms in the collections framework. Yesterday we saw, right? In the collections, there is a utility class called collections is a utility class. right? Which provides some methods which we can directly use. So this collections class also contains one method called sort, which will sort. Let's suppose if we provide it as a list of integer, it can easily sort based on the integer value. But to this sort, if I provide an object, let's suppose I have created an object called student. I am providing a list of students object. Now, can it directly sort the students? It doesn't know, right? So if we want to sort an objects, we need to provide some sorting algorithm to this function. Some sorting algorithm we should provide based on which it will sort the students. So that algorithm or that part with using which the collection framework should sort, it is provided using comparator interface. Okay, it allows sorting based on any criteria defined by the developer. Okay, and where do we use it? We use it in lambda expression or anonymous class. Anonymous class we have studied. Lambda expression we'll study it in the next topic, but they are used in the lambda expression. We'll see how they are used. Now, if it is an interface, if I show you, if you want, you can open this link and also try copy paste the code if you want to run it. See, comparator, it's an interface. It is in present in which package? Java.util. Okay, it is in java.util. And how do you identify it is an interface? Keyword. Keyword is there, na? Interface. And what does it denote? It is a very good. It is a dynamic data type that we have to define. Any class which is implementing the comparator, it should define the data type it should operate on. Why? Because we can create comparator for any object, for any data type. Like it could be integer, it could be some class that we define. And it has how many methods? 2 methods, compare and equals. Okay, what compare do? In this compare, we will pass 2 objects, right? And it compares the 2 objects and then it returns the negative integer. When will it return negative? If the O1 is less than O2. O1 object is less than O2, it will pass any negative integer. What do you think? When will it pass 0? Very good. When both are equal, it will pass 0. Okay. And positive, when will it return positive integer? When O1 is greater than O2. That we have to define the compare function like this. If O1 is less than O2, we should pass a negative integer. It's an int, right? Which should return negative. If both are equal, we should return 0. If O1 is greater than O2, we should return positive integer, int. Okay. And that is one method. Another method is equals. And what does equals do? It checks whether the other object, see this equals now, it will be present in some class. So it is an instance method. You know, right? What's the instance method? See, comparator. Here, I have defined one comparator. Okay. What this type of this declaration or declaration is called? We have studied, right? What this type of declaration is called? Anonymous class. Right? Anonymous class we have studied. It doesn't have any name. It's just an interface. We compare it. It doesn't have any name. So that's anonymous class. So see, you are creating an object comparator and you are overriding compare. Okay. See, it also has equals, and what equals will do? The reference object with which to compare. If the specified object is also a comparator and it imposes the same ordering. So let's suppose if we have created a comparator and we want to check with another comparator for the equality. So there we can will call it a equals. If both are equals, what we will return? If both are equals, we will return true, Boolean, equality check. Okay, we'll have one more comparator. We'll call the equals with that comparator. And if both are equal, we'll return true, else we'll return false. So we'll take one example of this comparator. We'll run it. So now what we are trying to here do is we are sorting the string. We have to see you got some string in the list. If we sort this string in the natural ordering, like currently if we sort it, what should come first? A, then B, then C, then D. But here we want to change the sorting order. What we are saying here, the string which with minimum length should be smallest, and the string with the largest length should be the largest number. So we are changing the sorting thing. So now what should we do? Now we have to create a comparator and define the logical ordering, right? Define the sorting ordering. Okay, now let's create a comparator. It's an interface. We implement an interface. So which method we have to override to compare? We have to override compare method. And here what it will get? It will get, here we are defining the comparator for what data type? String. And that is here we have defined string. You're getting it? See, here we are taking the dynamic data type, but we have to pass the data type that we have to work on. How we are passing it? By in this diamond operator, I think it is called, right?
Earlier we are passing to the arrays like the practice.
Here,
New arrays is that.
here also you are saying, so she correctly pointed out, she's saying we should pass here also, because array list is also expecting some dynamic data type. So how it is getting, it should work on string, even though we are not passing. So see, if we are getting, it is an improvement on the Java side, because since here we are passing the data type. In this variable, we are passing the data type string. So here the Java is able to identify ki, okay, this one will work with string. It is automatically able to infer ki we are working on string. So it is not required to write string here also. But if you write it, it will also work fine. But usually to avoid any code or just normal practices, since it is able to identify string here, we don't need to write it. It's a redundant. Okay. That's a good point. So, but we can write and we can avoid also. Why? Because we are getting it from here. Here it is compulsory. Like here, if you don't pass it, it will throw an error. So you have to definitely pass it here. Here it is optional because it can get from here. Now, we are defining a comparator. We are overriding the function. Now tell me, in this comparator, two objects will come for comparison. What will be the type of two objects? A string. Now we have to define the ordering based on the length. What should I do? What should I do? Let's suppose if we want to find it, what we'll do? I get the length of the string s1 dot length int object1 length is equal to this, right? Then get the length of we have to get the length of another string object2 s2. Okay. Now tell me, what should, if the string 1 is smaller than string 2, what should I pass? Smaller than what should we pass? What number should we pass? Negative. So if the object1 length is smaller than object2 length, I can pass negative number, any negative number. If object1 length is equal to object2 length, what should I pass? Very good, 0. It will denote that both strings are same. Okay. Else, what is the condition left? If objective length is greater than objective length, what should be passed? Positive. So see, this is how we are comparing, we should write. And to do this, Java is already providing a function to integer dot compare. We can use this also, which will compare to integer and it will return a negative value if x means if this is less than this, it will return true. If this integer is equal to or if greater than, it will return positive. That's what we have done. You got it? How it will compare? Okay. Now we have defined the comparator. Now where to use it? We have to use in the methods which is expecting a comparator. Okay. I talked about that we are using collections.sort to sort the okay. We are using collection.sort to sort string, list of string, and sort based on the length. We have defined the logic here in the comparator, and we have to pass this instance of comparator. Where do we pass it? Here in the collections.sort. So if you see the definition of this function, what it is expecting, a list and the comparator. We have defined the comparator. So it is doing this, and then it is calling a sort. It is passing a comparator. See, this comparator it is passing arrays.sort. It will use the comparator here. See, time sort, it will pass the comparator like this. It will work. Now for each object, each two object, the comparator will be called and then it will sort. If you want to see, I am passing 4. Let's see how many times the comparator is called. See, it has called, it will pass two objects, Bob and Alice. Now it is checking who is smaller, Bob and Alice. Okay. Are you getting it? This function is now calling our comparator to check between two objects, which is smaller. Now in between Bob and Alice, which is smaller? Bob. Okay. So it will return -1. Now it is again checking for Charlie and Bob. It is checking these two. Now it is checking Charlie and Alice. Now it is checking between these two. It is checking David and Alice. Now it is checking David and Alice. Now it will check for David and Charlie. See, it is checked for all. Now see, is it printing correct? See, it is printing Bob is first, then Alice, then David, and then Charlie. That's how you define a custom ordering. Okay, that's the use of comparator. Now let's move on to our next thing. So we have, even though we have used comparator to define our own logic of comparator, we can write comparator like this for any of the object. Like currently it was string, we can also define it for any other object. Here we'll define the logic. Okay. Comparable interface. There is one more interface called comparable interface. Now what is it used for? Again, it is used to define a natural ordering for objects. It is used to define for natural ordering for objects. So, okay. So this interface imposes a ordering on objects that implements it. The natural ordering is used by multiple methods called collections.sort and arrays.sort to sort an object. So see here in the last one, right? In the earlier example, we were explicitly passing the comparator that this collection sort function will do. Okay, let's suppose if I don't use comparator, it will also sort it now. Are you getting it? Now I have removed the comparator reference from here. Now what will be the order of sorting? Same as length. Where are you passing that it should sort by length? Are we passing any reference of comparator in this function? Who is sorting? collections dot sort. Earlier we were passing the comparator reference, right? Using which it was sorting the list. Are we passing it now? So now what should be the basis for sorting? It will sort based on alphabets, right? It will sort the based on alphabets. So for the string, the natural sorting, like if we don't explicitly define any custom sorting, the natural sorting order is the alphabet. Since A comes first, it will be lesser than less, then B, then C, then D. Okay, if we run it, and if we see the names, so see, Alice is first, Bob is first, Charlie is first, David is first. So the sorting based on the name, we call it a natural ordering. We have not defined it, right? Naturally, it is sorting based on the alphabets. So if we want to change the natural ordering of any class, are you getting it? See, I am not passing it here, but I want to change the natural ordering of the sort of this string. Okay, what should I do? Now that class should implement the interface called comparable to change the natural ordering while sorting. Okay. The purpose is to allow objects of class to be compared to each other for sorting purposes. Okay. And this comparable is defined like this. Again, it is taking a dynamic data type that we are not aware of. And it has a function called compare to. Okay. We'll see the use. It contains only a single method compare to. What will do? It will get an object. Compare to a class will implement. It will be an instance method. So it will that instance method will get a reference of another object. Okay. It will return a negative integer if the current object is less than the past object. It will return 0 if both are equal. It will return positive integer if the current object is greater than past object. Okay. Now let's implement it. Let's implement a student class. See it carefully. I have implemented a class. Okay, where it has a name and age. Let's not for now override this. Don't use any comparable. Forget about comparable. Forget about this. I have created a student class. Okay. Now, what I want to do is just this toString we have studied. We are just overriding the toString, which will give me a string. Now I am trying to use the sort, okay, on this students. See, I want to sort this student. So what I have done, created and multiple objects of student. Are you getting it? We have student. How many instance fields we have? 2, name and age. Okay, these are the methods getter and setter. Now what I'm doing, creating a list which will store multiple objects of type student, right? Type student. How many objects we have created? 5 objects we have created. Now I want to sort it. Now, what do you think? Based on what I should sort the student? Should I sort it based on name? Should I sort it based on age? Like for your you want to sort based on age. Like if I'm having attendance register, what is the sorting order there? Name. And if we stand in the queue, how do we sort it? Based on age. Like smaller one comes in the front end like this, right? So there is a custom ordering. In the real example also, there is a custom sorting order that we follow in each scenario. So it means it is our responsibility to provide that custom ordering. Okay. So what was one method that we discussed last? Create a, implement a comparator, compare to object. Now another is to define a natural ordering or to define a default ordering for that object. Okay. Let's suppose now I'm using sort on the students. So to implement sort, what it is expecting? It is expecting that the object should implement the interface. If we want to sort any object, okay, so it is expected that the class should implement comparable. Okay, to implement comparable, what method do we need to override? Compare to okay. So in this interface, we have to define the type also that this comparable will work on. If you see the comparable, it is accepting dynamic type. So here it will fail because it should operate on what should operate on type. What is the data type this comparable is operating on? Student. We are working on now student. We are defining the ordering for student objects. Okay, so we'll pass here student reference. So here we have defined a method called compare to. This is an instance method. Yes or no? Is it a static? It is an instance method, right? It will be called using object or using class name? Using object, right? It will be called using an object reference. So here, when the method will come to here, this will denote what? The current object whose reference we have called this method, and other is some other student object reference. Got it? Now we are comparing these two. Here, what comparison we are doing is, first we are comparing based on the age. If the age is less than or smaller, we will compare by the age. And if the age is equal, like if both age is equal, then we will compare it by the name. First, we are comparing with the age. If the age of both the students are equal, then we will compare it by name. This is our ordering, or that's what we have defined to compare two students object. Okay. Now, if we run it, let's see. If we debug it, it is sorting. Let's see what does it do. The collection sort, we have called all the 5 students. Now, what should come first? Charlie should come first because Charlie's age is less. It should come first. Then Alice. Then what do you think between Bob and Eve? What will come first? Eve, Bob, because since age is same, but now we are sorting by the name. Then Bob, then Eve, and then David. Now let's see. It is sorting now. It will call compare to for each 2 objects. See, compare to is called. Now the other student it has called is Alice, and it is, and the current student is Bob. Are you getting it? This means the current object reference, we are comparing Bob with whom? Alice. Okay. Like this, the Java will call for every student's object. Now it is calling Bob with Charlie. Like this 3 times 4, 5, 6, 7, 8, 9. 8 times it has called both of for all the students. Like it has compared Alice with Bob 1, 2, 3, 4. Then Bob needs to compare with Charlie 5, 6, 7. Charlie needs to compare with David. Like this, it will manage and then it will sort it. Now, if you see the sorting order, what should come first? Charlie, then Alice, then Bob, then Eve, and then David. You're getting it? That is how we can define the natural ordering, because here we are not passing any comparator. This collection dot sort, there is another functions it was mentioning. There will be lots of sorting function. Arrays dot sort, and here also I am passing students. What does it expect? Okay, it should it's only working for integer array. But there would be some other functions also which is expecting some list. There, if we don't pass the comparator, the natural ordering will take care of comparing it. Getting it? So that's how that's the purpose of comparable interface. So for the sorting, what two interface we read? One is comparator and one is comparable. Comparable, where do we define? In the class comparator. Outside the class, we pass it to the sorting function while calling the function. Okay. Now we'll see collections class. We'll see few methods of collections class which provides a sorting. So the collections class, it provides multiple utility methods for manipulating, traversing, and all the collections. It also provides the methods for sorting also. Okay. What all sorting method does it provide? All these four. Have we used this? In the earlier example, we used this, right? Which interface did we use here? Comparable, right? Last one. This one. Comparator. Here we are passing a comparator. Now tell me, if I pass it here, the comparator that we have defined. Let's suppose I am defining a comparator. I'm defining a comparator for student. Now I want to sort only based on student's name. Okay. Now what should I do? I want to sort based on student name's length. What should I do? What should I write here? Is only two things you tell me. What should I write here? I'll get S1 and S2. Then what should I do? Come on. I should get the name, right? Name dot length. S2 dot name dot length. And then I can compare based on length. And I pass the length comparator here. Now tell me, I have passing comparator also, as well as I have defined compare to function also. Now, which one it will use? Will it sort based on the length of the name, or will it sort based on the age? Now, according to the length, the Bob will come first, but according to age, Charlie will come first. Now tell me what should come. What it will sort based on.
First stage.
First age, then name. So it will not use length. It will not use length. If it is not using length, then what's the use of passing the comparator? If it has not to use the length or any comparator that we have defined, so what's the use of passing the length? So why are we?
The last step, expect the comparability. It's implementing the comparability.
It's implementing the comparable. So what did I say about comparable? It defines the natural ordering. If we do not pass any comparator, then by default, exactly, by default, it will call this compare to. But since here we have defined the comparator for this sort function, it will pick this comparator. No? Why will it go to this compare to? If we have already defined the comparator to compare two objects, then why it will go to its natural sorting? Are you getting it? There are two things, right? Comparable, you defined, it's good. But comparator also, it should override it because you want to change the sorting. Like he said that now I want to sort based on the length. I can't call multiple compare to, right? I can't call, because here we can have just one natural ordering. If we want to change the sorting in some other place, what should I do? I should then implement a comparator and then pass that comparator to a sort function, right? So that's the use of the comparator. Reverse, what reverse will do? Reverse the order of elements. Shuffle it will randomly, it will shuffle the elements in the list. So these are the, let's take an example and understand the example. Here what we are doing, sorting a integer. Okay, if I debug it will sort the numbers. What should be the natural ordering of sorting? 1 will come first, then 2, then 3, then 5, and then 7, right? So numbers will become, okay, if you sort the numbers, numbers will become, first it will come 1, then 2, then 3, then 5, and then 7. Okay, now here I'm passing the sort, but here comparator I'm passing, and here what I'm passing in the comparator, dot reverse order. What do you think what dot reverse order will do?
For the item.
Exactly. It will reverse the natural ordering of the object. Earlier, by default, it was treating 1 as a smaller number. But since you reverse the order, then after it will treat the larger number as a smaller number, right? Let's reverse the order. And here, if you want to change the sorting, you have to pass the comparator in the sort. You can't. Now, if I see the numbers, the first one will be 7, then 5, then 3, then 2, and then 1. It has reversed the sorting. Now shuffle, what shuffle will do? It will shuffle the numbers. If you see numbers, the 5, it has randomly shuffled the number. Like 7 was on the top, but it has randomly shuffled it. You don't know the order, it has randomly shuffled it. In the same manner, if you want to sort the names are sorted based on alphabetically. So names, either Alice is first, then Bob, C, D. Now, comparator comparing. What we are doing here, we are passing the comparator. Now, what do you think? What we are sorting based on? Length. See, now if we see the names, then Bob is first, then Alice, then David, and Charlie is highest length. It is coming at the last. Okay. Now reverse. What reverse will do? So what is the natural ordering? Alphabetically, reverse will be the, it will reverse the natural ordering. So now Charlie will, no, sorry. So basically reverse will do, it will reverse the, here reverse, it will reverse the order of elements. It is not sorting it, or it is doing, it is reversing the order of elements. So see here, let me again run it. So see, reversing the sorting was done by where? Here, collection.sort, where comparator, we have to define the reverse order. Okay. Here, this reverse function, what it will do, here currently Bob is there, Alice is there, David and Charlie, BADC. It will bring Charlie to the top, David to second, Alice to third, and Bob to last. So BADC will become CDAB. CDAB. Reverse means it will reverse the ordering. It is not sorting, it is reversing the ordering. Whatever is at the first will come to the last. Then next one will come to the second last, and like this, it will reverse the ordering. Shuffle means, what shuffle will do? It will just shuffle, randomly put the elements at some random place. Okay. It's the function of the shuffles. Did you get it? So reversing, what did we passed? Comparator. So there are two ways. Either you implement the comparable. If you want to have different comparison, you can pass a comparator interface. So since reverse order, this reverse order comparator is provided by the comparator itself. So we don't need to define it. When we have to define, when there is some custom ordering of the objects. Okay. Now let's take another example where we are sorting a. We have taken this example. We declared a student, right? Implemented a natural ordering, and here they were comparing first on age and then on name. And here also we have defined a comparator which was comparing based on the length of the name. Now here you are passing the comparator. Again, here you are passing the comparator. What it is doing? On the based of age and then reversing it. So after this, what will happen? After this, so see, before calling the sorting, this is the status. Alice is on top, then Bob, then Charlie, then David, then Eve. So now after this, what will happen? Which will come on top? You don't think David will come on top?
David.
By age, and then we are reversing it. Whose age is the largest? David, right? And the smallest is Charlie. Let's see. If I see, David comes first and then the Charlie. That's how you can specify different ordering. And we have inbuilt functions also. And if you want to implement your own functions, you can also do it. Okay. Here comparing, you are passing this. This is we call a function interface. We'll discuss in the next topic. But yeah, that's how you specify. You can keep in mind. Okay. That's about the collections. Some utility functions about collections, sorting, as well as shuffling, reversing, and all you can use. So mostly we use sort. Remember this, you can sort if you use the if you don't pass the comparator, the natural ordering will be used. And for the custom class that you define, you have to implement what? Comparator or comparable. To use natural sorting, you'll use comparable, else you can pass comparator. Okay. Now iterator and enumeration. So what is iterator? We discussed. Iterator is to iterate over elements. Okay. It provides the methods for accessing the elements of a collection and is a part of java.util package. So if you see, if I show you iterator, sorry, this is the wrong one. Java.util package iterator. This iterator is defined in java.util package. And what is it? It is an interface working on a dynamic data type. Okay. And how many methods it has? It's an abstract method called hasNext. We have studied yesterday what it will do. What it will return? True or false if there is any element to traverse. Next will return an element. Yes or no? It will return the next element in the iteration. Remove will remove that element. For each remaining, there is a default implementation present. What it will do? it will traverse through the remaining elements. Okay, which one? So if we want to implement the iterator, which all methods should we implement? Next, as next. These two are mandatory one. Rest are the default one. If we want, we can update, or we can override, or we can not. We can skip to override. So iterator, it allows sequential access to elements in a collection without exposing implementation of collection. They are used with collections like array list, linked list, and hash set to traverse and access the elements. So how many methods does it have? It has hash next, which returns true if there are more elements in the collections, else it will return false. Next, it returns the next element in the collection, else it throws no such element exceptions if there are no more elements. Remove, it will remove the element returned by the next. Each remaining, it performs the action. So you provide an action. It's a functional interface. You provide some action to do on each of the element present. So first we'll quickly see the basic example of iterator. Then we'll create our own iterator. Okay. So here what we had defined, a list containing string object. Now fruits is the array list. The iterator will return a iterator. Iterator is working on what data type? String data type. It has returned an iterator. Okay. Now has next will return what? Is there any elements present to traverse? Yes or no? Yes, right. We have not started traversing. We have 4 elements to traverse. So it will return true. True. Next means it will return what? Apple. Since we are on first, then we are printing apple. See, we are printing apple. And now it is checking if the fruit which is returned, if it is equal to banana, then we will remove this banana from the list. Okay. Is it equal to banana? No. Has next, it will return, will it return true? How many elements we have yet to traverse? Oh, 3 more, right? 1 we have traversed, 3 more we have. So it will, fruit will return banana. Now, if you see, currently fruits has 4, apple, banana, cherry, dates. Now fruit is banana, right? What it will do, it will remove that from the list. Now, if I see the list, you will find only cherry, dates, banana is removed. So what you will use, iterated or remove that element. Okay, remove this supports function remove, which will remove that element while traversing through iterator. Okay. Again, this. Now, once we traverse all the elements, it will come out the loop. Now we are just remaining array list after removal is it has removed banana. That's how we traverse the common data types. Now, let's create a code where I can implement my own iterator. I want to implement my own iterator. Now, to implement my own iterator, what should I have? Which method should I implement? To have my own iterator, which method should I implement? Abstract methods. What are the abstract methods here? Has next and next. Has next will return true if there are more elements to traverse, and next will give me that element. Okay. I have defined a custom list, and if I want to implement the this iterator, I will implement which interface? Iterable interface. Okay. So here I am implementing iterator interface. Okay. See, custom list class I have defined. In this class, what I am storing? An array of elements of type int. Then I am storing a size. What is the size of the elements? Okay. This is the default constructor, and I should have a method to add to this list. So if what I'm checking, if size is less than the length. So what I'll do, I will insert a element into the array. Are you getting this point? But if size becomes like if we cross the given capacity of an array, then what will type array capacity exceeded? Because we once we define a capacity or size of an array, we cannot update it. So let's suppose if we are defining a size 10, then we can only store how many elements? And after 10, if we want to store more elements, it should throw an exception, an error. So it's a kind of a custom implementation of an array list, but with a static size. Okay. Here, what we are doing, we are defining an iterator for this list. And in this, we are passing a class called custom list iterator. Okay. So now what it is doing, this is responsible to pass an iterator. See, if I implement iterable, what does iterable denote? We have discussed, right? Iterable, all the collections are implementing this iterable. So if I define a custom class and if I'm implementing iterable, it means it should return me an iterator, an object of type iterator. Yes or no? Okay. An iterator is again an interface. So to implement the iterator, we have to implement as next and next. So see here, since it's a collection, I'm implementing iterable. If I'm implementing iterable, I should return an object of type iterator. And iterator, I am defining it here. This is again a class which is implementing an iterator working on data type integer. And here, how many methods should I implement? Override 2, has next and next. So has next. So see, in the iterator, I have a current index. What does current index hold? How many items I have traversed till now? Are you getting it? Let's suppose I have a int array of size 1, 2, 3. Okay. How many index I can traverse till 2? I can traverse 0, 1, and 2. Okay. Size is 3. You keep this in mind, right? Now my iterator, when it will be traversing, it should have a note of how many index I have traversed. Yes or no? At the, like, if I am starting with the first element, what will be the first index to traverse? If I am starting, the first index will be 0. Very good. That's why the current index will always be 0 when you are first starting the iteration. Okay. If I'll call has next, what it will check? Has next will check. How it will check? If my current index is less than, it's less than 2. If I have already read the second index, it means the last one. Do I have anything else to read? Yes or no? If I have read this 3 element, do I have anything else to read? No, right? So if I have read the index is equal to 2, I have nothing to read. So in that case, my has next will return false. So here, with the current index, if less than size, it will return false. In the next, what I will do, I will check if I have any element to read. If not, I will return the current index starting from 0. And once it returns the current index, then it will increment. Getting it? So it's as good as doing this return current element. Are you getting it? Now, if I read the first element, the current element will be 1. It will return 1 and current index will become 1. Right? Initially it was 0. After reading first element, it will become 1. Okay. Remove, we do not support the removal. So this is our custom iteration. So now what I'll do, I have created a custom list, add 3 elements, create an iterator, and then I'll keep on checking if it has next, return me an element, else don't do. Let's debug also. If I debug it, the iterator list.iterator, it will call this new custom list iterator. It will return an object of this class, okay, where the current index is 0, size is, what size we have defined, 3, okay. Now let's iterate. Now it will go to this iterator has next and outpost. So if I put a breakpoint here, now let's see. It is calling next. Next will return. Current index is 0, size is 3. 0 is less than 3. Yes, it means it has elements to traverse. So it will get the first element. The first element is 10. The first element is 10. It will get 10. It will do current index as 1, and then it will return current element. We'll pass it. Then again, we'll check for has next. 1 is less than 2, 3, yes. Because we have how many elements more to traverse? 2 more. Okay. It yes. Then it is getting the next element. What is the next element it will get? 20. And now current index will become what? 2. Now we are on the second element. We have one more element to read. Yes, has next will return true. We'll get a next element and it will give us the last element. Okay. And then again we'll call has next. Current index will become 3. 3 is less than 3. Is 3 less than 3? No, no. So it means we are at the last element. So it will come out of this loop. So that's how you implement custom iterator. Okay. Another is enumeration. So enumeration is also an interface which is used to iterate through elements in a collection. So, but enumeration was earlier used. If you check about enumeration, it was also an interface which is used to traverse through a element. And it has only 2 methods. Has more elements, it will return true if it has elements to traverse and the next element. Now, what's the difference do you see in the iterator and enumeration? Has next, this also has iterator. If I talk about enumeration, right? See, enumeration, it has more elements. In iterator, what is this element? Has next. It was having has next. Okay. Now, in enumeration, we have has more elements. Next element in iterator, what we have? What we have? Next. Okay. But in iterator, we have more functions called remove. What remove do? It will remove the element that you have traversed, and also one more function called for each remaining. Do some action on remaining elements. So it has 2 extra methods as compared to enumeration. Okay, that's the difference. So it was created before in the first version of Java. It was there before the iterator interface, and the older Java collections like vector and hash table, they all use the enumeration. The new collection like ArrayList and all, what they use? The iterator. Okay. So currently, if we want to implement some iteration, we should use iterator. Okay. But enumeration, we should have some idea because some legacy code base, some earlier code base is reading it. So we should have some idea. What's the difference? Enumeration does not have a method to remove the elements. And iterator supports concurrent modification detection, but enumeration does not. Like in the iterator, if the same collection multiple threads are executing it, it will identify it and will throw some exception. But enumeration does not, it is not thread safe. It has two methods we have seen, has more elements, return true if there are more elements in collection, and next element will return the next element. So this you can try an example. The vector is the old collection. Here we define a vector, put 3 elements. Then we use method called elements to get an enumeration. And then we call has more elements, get a next element, and then print the color. That was about the enumeration and iterator. Okay. Now we'll study more classes like called random class. So what is random class? What do you think? With the naming, what does it suggest? It will give us some random numbers, right? In your code, or let's suppose you roll a dice. If you want to create a Java code or program or project where you are simulating rolling a dice. So what you will say, you give me a random number between 1 to 6, right? Rolling a dice. If you roll a dice, what happens? You come up with some random number between 1 to 6, right? So random class is used to generate a stream of pseudo random numbers. I'll explain what pseudo random is. The random instance class is generate a pseudo random numbers. Why pseudo random? In the English, pseudo means false. Very good. It looks like random, but it is a kind of false random. Why do we call it false random? Because the numbers which is generated by a random class are not truly random, because to generate some random number, we should have some algorithm. Okay, random class must be implementing some algorithm to generate a random number. Now that algorithm is deterministic. Deterministic means, see, I'll give you one example in the real life. Let's suppose from your home to institute, there are 4 roads for you to travel. Okay, 4 roads are open. I know that between home and institute, you have 4 routes to travel. So for me, you can take any road to travel. Yes or no? Like, let's suppose there is road 1, road 2, road 3, road 4. Can I say with confirmation that you will take any specific road? Is it confirmed? I cannot say with confirmation, right? You can take either road because there are 4 roads available which will take same time, same traffic, same. So we can say that you will randomly take one road out of 4 to travel. It is random. Okay. But for you have decided that on Monday, I will take road 1. On Tuesday, I will take road 2. On Wednesday, I will take road 3. And on Thursday, I will take road 4. That you have decided. Or let's suppose road 3 on Tuesday, Wednesday, road 2, like this. You have decided. On Friday, again road 3, Saturday, road 4, and Sunday, road 1. Like this, you have decided. Now, are you taking random road? Now also, like in one day, you are taking R4, R3, R2, R1. But if I come to your pattern, your algorithm or your pattern using which you are deciding the road, can I now find out which road you will take? Can I now find out? Because based on which algorithm you are deciding the road? Based on days. Based on days, you are deciding the random road, because you are saying that I have to give each road a same time. Like I should if I have 4 days, I will traverse one road each day. I will not repeat it. I will traverse one road each day. But since you have defined a day of a week to a particular road, now it is deterministic. Now I can determine that which road you will take which day. Even though it is random, but I can determine. In the same manner, the Java, while providing a random number, it also have some algorithm to generate a random number, but that algorithm can be determined. That's why, since it is no longer random, right? Like if I'm able to determine it, it looks like random, but it is not random. So we will call it a pseudo random numbers. That's why, since the algorithm that it is using to get a random number is deterministic, we can say that we are saying that it is pseudo random. And why it is deterministic? Because it is generating a random number based on a seed value. There is some seed value, some initial value. Here the seed value was the day of the week, and here we have some seed value, some number. So instance of the random class are not thread safe. If you want to have thread safe class, you should use thread local random or secure random. Now let's before this, let's quickly understand what is the term that we discussed. So pseudo random numbers is numbers that are generated using deterministic algorithms that but appear to be random. It is determined, but it appears to be random. Why? Because they are not truly random, because their generation depends on some initial values. We have understand with an example. What is the deterministic nature? It means given the same conditions, given the same values, given the same seed values, a pseudo random number generator will produce the same sequence of numbers. Here on the same day, you will take the same road. On every Monday, you will take the same road. Here also, if you give the same initial seed value, you will get the same sequence of random numbers. And why do we use this? Because it is crucial for debugging and testing. Because let's suppose with some random number, if we want to debug it, find out the time or order and all, it will help us. What is seed? It is some initial value which is used by the random number generator to start the random number generation process. The seed determines the starting state of algorithm. Okay. And default seed is if you do not provide any seed, if you do not provide any value, so the random number generator will use the current time in milliseconds as its seed value. So if you have called two random generator, see random generator R1 and random number generator R2 at the same time. Getting it? If you call it at the same time, then every call to this random number generator will produce same number. Even though it is random, but since it has called on same time and the seed value is same, it will produce same random number. If it will produce 1, it will also produce 1. If randomly it will produce 6, it will also produce 6, like this. Okay. Now, for the random class, what are the methods? There are few methods called random. It creates a random number generator using a seed value, and this seed value is random because we have not provided it. And you can also provide some seed value in this argument. It's a constructor. If you don't pass it, it will use the default one, which is the timestamp. And if you pass it, it will use the past seed value. Next int method, what it will do? It will return the next pseudo random number. It is uniformly distributed. What do you mean by uniformly distributed? Uniformly distributed means if I say provide me number from 1 to 10, okay, and if I call next int 10 times, all the 10 times it will give me 10 different integers. It will not repeat the integer unless all the integers are provided by this next int. Okay, so the probability of selecting each integer is same. That's what we call uniformly distributed. So each possible integer has equal probability of being selected. And for the int, the range is from its minimum value to maximum value. There's another method, next int, where we provide the bound. What do we call bound? Next int, it will give me number from minimum to maximum. But in case of roll dice, I need to get a number from where? From 1 to 6. So we have to bound it. Okay, I have to bound it from 6. Okay, so if you use the bound, it will pick the number from between 0 inclusive and the specified value exclusive. So here it will pick number from 0, 1, 2, 3, 4, and 5 because 6 is exclusive, it will exclude. Okay. Next long again, next int, it will return the next pseudo random in the long value from uniformly distributed. Next is float, it will provide the float, double will provide the double, next boolean will provide the boolean number, and next bytes will provide the random bytes and will place this in the array. Okay. If you want to, we can quickly see what is it return. Random. So what we are doing, we are creating a instance of random number. Okay. It will provide next int will from minimum to maximum. So see, randomly it will provide some number minus 570 within the range. Okay. Now what we are doing, we are providing a range. Now the number will range from 0 to 99. So here it will return me number from 0 to 99. It will return 19 randomly. Long again, from long minimum to long maximum, it has given me this number. Float again, it will give me some float value. Double, it will give me some double value. Boolean will give me some random Boolean value, false or true. A byte array, it will give me some random byte value and it will put into this byte array. See. Okay. Here, what I am doing, I am providing the initial seed value. Now, if I call this, it will again give me value from integer minimum to maximum. That's the usage of the different methods. There is one more method. See, if I run it, see the result. Now, what we are doing, we are creating two random generator using same seed value. Now, the order of number for each one, let's see here. I'm calling 5 times next int. So the random one has generated this value randomly. But since seed value was same for both the random number generator, the second one has also generated same. So next element, it generated this value. The another object has generated the same value like this. So since I understood what's the purpose of seed, like since you have kept the same seed for both random number, random class, it is generating the same random number. That's, and once you change like random 3, if you give a different seed, so see, it will give us a different value. Getting? So that's what the purpose of seed. Properties. So last time we discussed about the properties. So every project, everything will have some properties file, right? Here also we have properties file. Let's suppose it's a Java project. We have some properties files here. So what are the properties files? A collection of key and value. Some key value would be there. Yes or no? Right? Some key would be there and some value would be there. And when you'll create a project and all, you will use this properties values a lot. Okay. In the separate file, you'll create a properties and then you'll have a key value pair. Okay. So Java, to support this key value pairs and the properties, it has a class called properties class. This class represents a persistent set of properties. We have to persist it. How we are persisting it? In a file name called dot properties. It is a constant. It will never change. Let's suppose Dynamo endpoint, the URL of my DynamoDB. Here you can have some MySQL URL. These all are the constant, fixed. You will define this. So instead of defining in your class, what you will do, you will create one single properties file. And then you will define all your constant or all your URLs everywhere in one single file. Now, your Java code in your project, there will be multiple classes. And each multiple class will read a single properties file and will get the value for their key here. Let's suppose your MySQL URL, you'll define something. Now Dynamo endpoint is there. Now your Java class, which has a code for Dynamo, it will pick this value. Now there is another Java class which has code for MySQL connection. It will read this file. Okay, so you know the purpose. If all there are different files, they are referring to any properties, some static properties and all, you will define it in a single properties file, and you will refer this properties file from different Java classes. And it is in the form of key value pairs, where you have a key, then equal to, and then a value. And these all are a string. These are treated as a string. So the properties can be saved to a stream or loaded from a stream. What do you mean by stream? It could be either a file, some terminal, keyboard, or anything. There could be any string. But normally, what do we use? It's a file. It's a file stream. So each key and its corresponding value is a string like this. This is also a string, and this key is also a string. It is used for configuration settings, setting up some application parameters, internationalization, and managing application settings. Okay. So let's suppose if you are using hello in your system. Hello in French is something else. Hello in Germany is something else, right? To show in UI. So what you will do? You will create multiple properties file for each language and define hello as in their own locale. It's a practical usage that you will do a lot. A property list, it can also contain another property list as its default. So basically you can define a property list like this, and there can be another file which also has some property list, and it can act as default. So if we are searching for some UI, some key, if it is not found in this property file, it will search its default properties. Okay. And properties class, it extends hash table. Why hash table? Because hash is kind of key value pairs. That's why it does it. The constructors is properties, it creates an empty property list with no default values. And this properties, it creates an empty property list with the default values. So there are some common methods like set property. What set property will do? Each property it will set. Like here's a key. So I'll call set property. I'll provide a key here and its corresponding value. It will put the key value in the hash table or properties class. What get property will do? It will return the value for the provided key. It's a key value, right? If I give a key, I should get its value. Now, get property string default value. So what's the use? First, with the given key, it will search if any property is present. If the property is present, it will return that value. If not, it will return the given default value. Getting it? Load input stream. It is used to load the properties from a stream. Let's suppose I am defining a file. It will load all these properties into a class. And how it will load? It will store it as a key and then its value as a key, then its value like this. It will have multiple keys and their values. It is from an input stream. Input stream is used for byte, and here reader is used for char. Okay. Store means it will write the properties to a file from the code. Output stream for byte and writer for char, right? List, what list will do? It will print a list of properties to the given print string we have studied, right? Print string, and list will print a list of properties to the provided print writer instance. Okay, these are the common methods that we can use. Let's understand it with an example. So see what I am doing here. I'll debug it. What I have done, I have created a properties object. Now set property, what it will do? It will set it with the given key value pairs. See if I run it. Now if I see the properties, it will set with the key value pairs. Okay. Now what I want to do is I want to store these properties into some file. Let me take my local file. Let's again run it. So I have set it. Output stream will create a file output stream. It will store it. Here we are using try with resource. So after I come out of this loop, it will automatically close. It will automatically close the resource. See, I have created a config.properties. If I want to see it. Okay. You got it? So this is how it has created a file. Now here, store what it will do. It will storing this properties, and here we can provide the comment also. What comment we have provided? Database configuration. So see, it has added this comment and the timestamp when we created this file. Okay. Now here, what we are doing, we are trying to read the given file. But since I have to given the same path to read. Okay, now let me debug it again. Okay, loaded properties. What we are doing, we are creating a new instance and we want to load the properties that we have created here. Getting it? We created some properties, saved it to a file. Now we want to read this file and we want to create a key value pairs of properties while reading this file. So what should we use? We have to use input stream and function called load. So if we use function.load and if we check the loaded properties, we will see all these three entries. Okay. And get property, what it will return? It will return the value. See, it is the value. The password is the value. And this is how we store it, save it, read it, and then we can get the property and then how we set it. This is the basic functionality. And also, I also talked about some default properties. Let's also see this example. Okay. So now what we are doing here, we are creating again a properties object, setting some properties. How many properties we have set in this? 2, timeout and language. Now we are again creating a new properties and we are giving the already created properties as its defaults. Okay. Now in this new property, we are setting timeout. Okay. In this property, we have set how many properties we have set? 1, which is timeout. And the default one, how many properties are present? 2, timeout and language. Now, if we want to get a timeout from this property, what value will I get? 60 or 30? 60, right? Because it will first search in the properties. If it doesn't find any property in this, it will then search for the default. It will return 60. Okay. Now language, it will search for language here. Do we have a language in this property? No, it will search for default. Default, we have a language with EN. So it should return EN. Now language. Does any of the property has language? Sorry, country. Does any of the property has country? No, it will not return anything. But here we have passed default. We said now there is one more method called get property where we can pass a default value. If the property is not present, the default value will be returned. So since property is not present, it will return default value, which is US. Okay, that's the use of properties. Now there is the final topic called date class. Now, what is date class? With the name, we can say that date class is related to date class is for the presenting the date in our system. Just a second. Okay, it is used to represent any of the date. So date class, what does it do? It represents a time with millisecond precision. Okay. So in all methods of class date, which accepts or returns the year, month, date, hour, minutes, and seconds, the representation used are the year Y. Y is used to represent a year. Month is represented by an integer from 0 to 11. 0 means January, 11 means December. Date, the day of month is represented by an integer from 1 to 31. Hour is represented by an integer from 0 to 23. The hour from midnight to 1 a.m. is R0, and from 11 p.m. to 12 is R23. Minute again represented by an integer from 0 to 59. Second is represented by an integer from 0 to 61. Why 60 and 61? It is for the leap year seconds. Like in the leap seconds, right? We have extra seconds. For this, it represents 60 and 61. So the date class has following constructors. One is a default one. What does it do? It allocates a date object and initialize it so that it represents the time at which it was allocated. Okay. So if I call new date, it will give me a time when I have called new date. And date long date means it here we pass a long date. It allocates a date object. And what time does it denote? It denotes the time. So see, in the date here, in the long date, we specify a milliseconds. We specify a milliseconds. So it will return the date starting from January 1, 1970 plus the milliseconds passed. Okay. Now you will ask, what is this epoch? Can you tell me what is this epoch? So if I tell you in the computer, right? If I tell you what is time, or what is a accurate time today, what you will say? It is 30 June 2024, 11:30 a.m. This is the time for you. You will define this. So it means the year is 2024. It means for you, the year has started from 0. Like what you have AD, before Christ, AD, and something was there. And here AD starts from 0 and we have crossed 2024. But there was some before Christ, like some before it also there was some period, some 10,000 or millions of years back also we have. So do we have a definite range here? No, it's all relative, right? Your time is all relative. You are saying from AD0, we have spent 2024 years. Okay, you have some reference. You have taken this AD as a reference to calculate 2024. There should be some zero. There should be some base based on which you will calculate the time. What you have said, we have spent 2024 years. We have spent June. It means we have spent January, February, March, April, May, 5 months. And we have spent how many days? 29 days. These all are relative, right? On some base, this all are relative. Now for the computer, what is the relative date? the relative date is this, January 1, 1970. So whatever time or it calculates on this basis. January 1, 1970. If you ask computer, what is your date or what is your origin and all, it will say January 1, 1970 this. So if I tell him, give me a time starting from this plus 10 milliseconds. Okay. So what it will give me? Are you getting it? What it will get me? 000. Let's suppose 1000 millisecond means 1 second. So plus 1000 millisecond, it will give me this. Right? If it is 2000, it will give me this. So here, what do we pass? A date, and here we pass a milliseconds starting from this. So whatever milliseconds we pass, it adds to this base and gives us that date. Okay. But there are some design issues in the date class. There are lots of methods which are deprecated. The constructions are deprecated. So we also have an option to use java.time package, which is introduced in Java 8. So, but since in many code or at multiple places, there's a date class used. So that's why we will study about it. Epoch, we know. An epoch is the date and time relative to which a computer's clock and timestamp values are determined. So the date and time in computer, they are determined according to the number of seconds, clock ticks and all, right? Milliseconds, nanoseconds and all that have elapsed since the defined epoch. And the defined epoch for multiple platforms is January 1, 1970. You remember that? Okay. Now, what are the methods of date? Get time, what it will return? Long means it will return the number of milliseconds since January 1, 1970. Boolean before date, when what does it do? It tests if the data, whatever date the current object has, is this before the specified time. After that means if the current date object is after the specified date. If it is after, it will return true. Here, if it is before, it will return true. Set time, what it will do? It will set the date object to represent the time in milliseconds. Like if you set time as 0, what date it will represent? If you do set time and then if you do 0, what date it will represent? It is saying set this date object to represent the time that is given milliseconds after January 1, 1970. If I set 0, what date will it represent? Very good. January 1, 1970, 00. If I do 1000, it will represent which date? 01. 1 second. Okay. Compare to, again, it compares two dates for ordering, which date is occurred before. ToString, it converts the date object to a form called DON, MON, DD, HHSS, this is it, bye. What is DOW? It's the day of week, Monday, Tuesday, Wednesday. MON is, it's a month, January, February. DD is day, 1, 2, 3, 4, 30. R is R, 11 minutes is MM is minutes, 30 minutes, seconds. ZZZ is time zone. What is our time zone? IST. Likewise, different countries, different nations has its own time zone. So which nation has highest time zone? Russia. I think Russia has how many time zones? 9 or 10, 11 time zone in its own country. In the one nation, we have 11 time zones. And India also, we were talking about having different time zone for Northeast. Why? Why Northeast? They were having different time zone. Because I think there the sun rises late. I hear Earth rotates from west to east and all. So I think we say that the sun rises early. The sun rises early in the east as compared to the west. So that will be the logic. Okay. But there are news to have a different time zone for the east. So currently 11:42 is there for all places in our India. But if they shift the time zone, like in Bangalore, if it is 11:42, it could be possible that it is 11:52 in Northeast if they come up with a different time zone. So it's then we'll run this example. Current date, it will return the whatever the current date is. See the time. It has returned the calendar. It is 2024. Day of month is 30. Day of week is 1st. Hours is 11. Minutes is 42. Okay, like this, it will return the complete date object. So current date, if I print this, January 30, 11:42, 44, time zone, IST is a time zone and it is a year. Now specific date, I am passing a number of milliseconds. So it will give me the starting from 1970 plus the given milliseconds, what the date is. So it is giving me this date. So after passing 163 is long milliseconds, we will have 1st October 2021 and this date. So current date before this specific date, it should return true or false. Is current date before the specified date? Come on, true or false? False. Is current date after specific date? True. Right. Dot get time. What it will return? The milliseconds. The milliseconds starting from which date? 1970. So we have spent 171972796445 milliseconds since 1970. And set time. What set time will do? It will set the date to this milliseconds after this. If I check current date, so now it is set to this value. Okay. Comparison. Is the current date is same. So comparison will return 0 because current date is same as specific date. See, the specific date also we have specified same time. So both are same. That's why it will return 0. And toString, it will return date like this. This is the week, October month, date, IST and 2021 year. That's how you define a time object. So there is last two topics. I have to rush. So I'll cover this in next class. We have 2-3 topics left. Tomorrow, can we come? Tomorrow evening? Yes? Tomorrow evening or today evening? Tomorrow evening, right? So it's just a 5 minutes. And then since tomorrow we'll meet, we'll do detailed exercise in hash map, list and all. Let's do it because they are widely used. So it's better we cover. 5 will meet at 5 to 7:38 we'll do easily. Okay. So I have uploaded notes, you revise all of them and then we'll meet tomorrow. Okay, yeah, that's all for the today's class. We'll wrap up this date formatting in the next class. It will take another 15 minutes. And then we'll do a lots of examples, exercises for the list, map, and set interfaces. Because in programming questions, interviews and all, coding questions, we mostly use list, hash map and all. Hash map array lists are the most common, hash set and so we'll do some examples also. Okay, yeah. Thanks a lot, everyone.